Number system part 2. Earlier I have discussed about decimal number systems. In this session I will start with binary number system. The binary name or the word comes from the original Latin word binaris, which means consisting of two. And these two numbers are 0 and 1. In decimal number system, we had seen that there are 10 numbers 0 to 9, and that is the reason it was having a base of 10. And now in binary, since there are just two numbers 0 and 1, that is the reason we have a base of 2. In decimal system, it was 10 to power 0, 10 to power 1, and so on. In binary, it is going to be 2 to power 0, 2 to power 1, and so on. In decimal, it was base of 10. In binary, it is going to be base of 2. So let's begin with discussion on the addition aspect of binary numbers. So when we add 0 and 0 in binary, we get an output of 0. This is similar to how you would expect decimal number addition. And when you add 1 to 0, you get 1. Okay, this is again exactly similar to how decimal number addition works. But now the change comes here. When you add 1 to 1 in decimal, you will get the number 2. Whereas in binary, when you add 1 to 1, it results in a binary number 1 0. The way it works is 1 and 1 gives you 0 and 1 gets carried over. So that's the result. You get a 2-digit number which is 1 0. Whereas in decimal, when you added 1 to 1, you got a single digit number of 2. Now this is what 1 0 is in binary as such is equivalent to decimal 2, and we will come to that and show how we convert a binary 1 0 into decimal 2 later on when we go into that detail. But this is the basics of how addition in binary works. Now using these rules, we will start deriving initial couple of binary numbers. So starting with the first binary number that we already know is 0. Okay. Now to get the second binary number, we'll use the simple logic of adding 1 to it. And when we do that, what do? 0 plus 1, that gives us 1, and hence the second binary number is derived to be 1. Taking the same approach, we will calculate the third binary number, and that is what we do is we'll take the second binary number, which is 1, we just derived, and then add 1 to it. So 1 plus 1 gives us 0 and 1 carried over, and that's why the third binary number is 1 0. Okay. Applying the same logic to the fourth number, we add 1 0 to 1 to 1 0, and when you see 0 and 1 gives us 1, and now I'm going to add a placeholder 0 in front of 1. Okay. And then when you add 1 and 0, that again gives us 1. Hence the fourth binary number is derived as 1 1, not 11 but 1 1. Okay. And then fifth binary number becomes in the same way, we add plus 1 to the fourth binary number, which was 11. I'm sorry, 1 1, not 11. Okay. So we add 1 to 1 1, and this is how it works. 1 and 1 we get 0, and then 1 gets carried over like this, and then we add these two ones, that results in 0 and then 1 getting carried over, and that is how we derive the fifth binary number. Now if we continue the same process, the next number 6 would be derived as 101, 7th would be derived as 110, and the 8th would be 111. Now if I had to put this in a tabular form, this is how it would appear. Okay. Alright. The next key thing about is about numbering of bits. Okay. The counting of bits start from the very right, and that bit is known as not the first bit but the bit number 0. Okay. And then as we moved from the right to left, the bit numbers are called 1, 2, 3 and so on, like this. Bit 2, bit 3, bit 4, bit 5, bit 6 and bit 7. So remember, the counting of bits begins from right, it is the bit number 0, and that's where as we move from right to left, the bit numbers are incrementing. So in all, if you look at these, how many bits are there? 0 to 7, in all 8 bits. But we don't call them as the first bit and the 8th bit. We call them as bit number 0 and bit number 7. Okay. Next property is since this is a binary number system and consisting of two numbers 0 and 1, the base is 2. Okay. And the position takes important here. So for the bit number 0, we have the position stakeholder 2 to power 0. And for bit number 1, it becomes 2 to power 1. And then as we move left, these numbers become 2 to power 2, 3, 4, 5, 6 and 7. Okay. So do remember this. The base is 2 because of being binary. Why binary? Base 2? Because binary has two numbers. And then the bit counting starts from the 0 position on the rightmost, and that's the reason you see the power of 2. What is the power of 2? 0. And then as we are moving from left, the power of 2 is changing from 1, 2, 3, 4 and 7. So bit number 7 has 2 raised to power 7. Bit number 5 has 2 raised to power 5. So this can be easily correlated. And then one more observation that will be interesting for you is to see how these numbers are positioned. So if you look at this 2 to power 0, which is the rightmost bit, if you see applying the same rule, any number to the power 0 gives 1. Okay, so 2 to power 0 can be written as 1. Okay, similarly 2 to power 1 can be written as 2, 2 to power 2 as 4, 2 to power 3 as 8, 2 to power 4 is 16, 2 raised to power 5 is 32, 2 raised to power 6 is 64 and 2 raised to power 7 is 128. So if you look at these, so as you move from right to left, each number is double of the previous one. So 2 is double of 1, 4 is double of 2, 8 is double of 4, 16 is of 8, 13 double of 16, 64 double of 32 and 128 double of 64. So this is another important point that you need to understand and remember. Okay. Now we come to the interesting part of how do we convert a binary to a decimal number. Okay. So these are the numbers that we had derived by addition one by one. What would be the first 8 binary numbers? Now we want to see how we can convert them into decimal. So let's take the first number. Okay, we know the bit positions are like this. Okay, so what we are going to do is simply take the first number as an example 0 and we multiply, right, put it next to the position 2 to power 0, multiply it like this, and then the result is like this: 0 into 2 raised to power 0. 2 raised to power 0 is nothing but 1. That's why you get 0 into 1 and the final result is 0. So for the binary number 0, the decimal equivalent is 0. Let's take the next binary number, which is 1, and convert it into decimal. So we'll apply the same logic. Put 1 next to 2 raised to power 0, multiply it, and then get the result. So 1 into 2 raised to power 0 is equivalent to 1 multiplied by 1. That gives us the final value 1. Hence, the binary number 1 is equal to decimal number 1. Okay. Moving on to the next number, which is the third binary number, happens to be 10. So let's take that. And now what we'll do is we will put the 0 next to 2 to the power 0 and the 1 next to 2 to power 1, like this. Okay, these are put like this, and then we multiply them, and then whatever is there we add them also. So there's, if you can see, we add a plus symbol there. So as a result, what do we get? This is what the equation becomes: 1 multiplied by 2 raised to power 1 plus 0 multiplied by 2 raised to power 0, resulting in 1 multiplied by 2 plus 0 multiplied by 1, and that what total gives us 2. So the decimal equivalent of binary number 10 is 2. Moving on to the next number, which is 11, we apply the same concept. Put the right 1 next to 2 to the power 0, put the left 1 next to the 2 to power 1, and then multiply it, and then add the result. So this is how the equation is going to look. Okay, resulting in the number 3. So this is how it will come. So we can continue doing like this and make progress. Now quickly jumping forward, we'll see how exactly a number of 8 ones. We have 8 digits, and all of these 8 digits or 8 binary digits are numbered 1. So we take all of them and put next to, how we are going to say is like this, next to all these, and then multiply by 1. Okay, multiply with their corresponding positions, and then as a result, what do we get? When we add, this is what we get. Okay, so the result of all the 8 bits which are put as ones, the equivalent of that in decimal is 255. Okay, so the key takeaways for this session that you should remember and try to make sure that you have a crystal clear understanding are: binary numbers consist of 2 numbers which are 0 and 1, and because of that it is known as base 2. For clarity, you need to remember in the 2 raised to power 0, 2 raised to power 1 and 2 raised to power 2, all of them have the base of 2. Okay. Next, counting of digits starts from the right, and the first digit or the bit is known as the 0 bit or 0 position. And then as we move left from right, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, the values double, because on the rightmost we had 2 raised to power 0, and then we had 2 raised to power 1, and then we had 2 raised to power 2, and so on. So 2 raised to power 0 is equivalent to 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4. So the values as we move from right to left, they double. And then the important final thing for this session is the method of converting any binary number into decimal, right? So do remember, whatever is the binary number, look at the position of that digit, place it next to the corresponding power of 2, multiply it with that, and then after putting all these put things in place, multiply them and add them together, and that will result in the value of equivalent decimal number.